Hey guys, welcome back to another video. In this video, we want to talk about one-way slabs. Let's start with describing what is a one-way slab. A one-way slab is a reinforced concrete floor panel that transfers load to the supporting beams in one direction only. Let's focus on this picture. In this picture, the slab is supported by beams and girders that are in turn supported by the columns at point A, C, D, and F. A slab panel can be defined as a portion of the slab between the two adjacent beams and girders. In this picture, consider the span Ly in the north-south direction is significantly larger than the span Lx in the east-west direction, such as Ly over Lx is greater than 2. In this case, the slab panel A, B, E, D transfer most of the floor load to the beam AD and BE. We can say the slab spans in the short direction, which is Lx, and it is considered a one-way slab. Now that we understand what is a one-way slab, let's talk about the moment resistance of a one-way slab. For design purpose, one-way slabs are treated as if they are composed of a series of beams, also called slab strips, placed side by side, as we see in this picture. Here we can see that each slab strip is considered as a rectangular beam with a width of 1 meter and depth equal to the slab thickness. As we can see in this picture, the primary tension reinforcement in one-way slabs always run parallel to the short direction. Depending on the direction of bending moment, reinforcement is placed either at the bottom of the slab for positive bending or at the top for negative bending. Now that we have enough information about one-way slab and moment resistance of one-way slab, let's start talking about designing a one-way slab. Here we are going to use this spreadsheet to design our one-way slabs. In our spreadsheet, AS is the area of tension reinforcement for a 1 meter wide strip of slab. AB is the area of one reinforcing bar, and S is the center to center bar spacing, which is denoted in millimeter. The analysis of a one-way slab is identical to the analysis of a properly reinforced rectangular beam. B is equal to 1000 mm, which is our strip width, and H is the overall slab thickness. Now let's move on to the spreadsheet. First, we have our FC prime, which is specified compressive strength of concrete. Then Fy, which is specified yield strength of reinforcement, and phi C and phi S resistance factor for concrete and for reinforcing bars. First thing that we have to do is to put a value for our moment due to the factor load. Here, let's say our factor moment is 100 kN meter. Then we need to add a value for our Ln, which is our clear span, and choose our support condition. If we click here, we can see that we have three options of simply supported, one end continuous, and both end continuous. Based on our Ln and support condition, we can use this table which is provided to us in Concrete Design Handbook and get the minimum required slab thickness. For 6000 mm clear span and simply supported condition, we can see that the minimum required thickness is 300 mm. The next step is to estimate the effective slab depth. For this, we have to choose our cover condition based on exposure condition of our slab. The options that we have are not exposed, exposed to freeze and thaw cycle, exposed to chlorides, exposed to earth permanently, and we can see the associated cover for each of the condition. For not exposed, we have a 20 mm cover. For exposed to freeze and thaw cycle, we have a 40 mm cover. For exposed to chloride, we have a 60 mm cover, and exposed to earth permanently, we have a 75 mm cover. After choosing the exposure condition, we can use this drop down menu to choose the bar size that we want to use for designing our slab. For this slab I want to use 20 bars, so we use the drop down menu and select 20 and here we can see the result for D, our effective slab depth, which is calculated using this equation. After that, we need to calculate the required area of tension reinforcement to resist our factored moment. AS required, which is the required reinforcement area to resist factored moment, is calculated using this equation. Now that we know the AS required, we can calculate the required bar spacing using this equation. The spacing needs to be less than this number. The next step is to compare AS required or provided to minimum required reinforcement per code. As we can see here, minimum slab reinforcement required by code is 0.2% of the cross-sectional area of our slab, and that is equal to this number, which is 0.002 times B times H. The next step is to confirm the maximum bar spacing requirement per code is satisfied. Using our concrete handbook, we know that the maximum tension bar spacing should be lesser of 3 times H and 500 mm. This cell is showing us the minimum value of 3H 500 mm and S, which was calculated above. Now that we know the bar size and spacing of our tension reinforcement, the last step is to design the shrinkage and temperature reinforcement. The required area for shrinkage and temperature reinforcement is equals to AS mean, which we calculated earlier, and we can see it here as well. From this drop-down menu, we can choose the bar size that we want to use for our shrinkage and temperature reinforcement. And in this cell, we can see the spacing required for the bar size that we chose. This is just to satisfy the AS min requirement. We have to compare this spacing value with maximum temperature bar spacing per code, which is lesser of 5H and 500 mm. This cell is showing us that S is smaller than 5H and 500 mm, so we are okay. Now that we are done with the design, we need to provide a design summary. Looking at last section of this spreadsheet, we can see the cross section of our slab, D, which is our effective depth, cover, our tension steel, our temperature and shrinkage reinforcement, and the slab thickness. We can see our tension steel size and spacing, and our temperature and shrinkage reinforcement size and spacing. Remember that the tension reinforcement always run in a short direction. Thank you guys for watching this video. Please subscribe to my channel, like this video, share this video, and if you want the spreadsheet, please comment down below and I will send it to you. See you guys in the next video.